Question number 12. Three equally charged small objects are placed as shown in the figure. The object A exerts an electric force on object B equal to 3 into 10 to the power minus 6 Newton. First question, what electric force does C exert on B? And the second one is, what is the net electric force on B? Okay. So as you can see here, we have three equally charges. So let us assume that the charges on these three small objects are Q charges. Okay. And the object A exerts an electric force on object B. That means the direction of this force is in this direction. So this would be FBA. And the value of FB is given, that is 3 into 10 to the power minus 6 Newton. And here from the figure only we can see the distance between this two charges. So here we have a Q charge, here also we have a Q charge, and here also we have a Q charge. Okay, so the distance of this AB is 2 centimeter, which is 2 by 100, which is 0.02 meter. And BC is given, BC is 1 centimeter, that means 0.01 meter. So first, with the help of this FBA, we are going to calculate the value of charges. So we know that FBA would be K into Q1, here both of the charges are same, so Q square by AB square. So FBA is 3 into 10 to the power minus 6, K is 9 into 10 to the power 9, Q square is Q square, and AB square is 0.02 square. So from here, Q square is equal to 3 into 10 to the power minus 6 into 4 into 10 to the power minus 4 divided by 9 into 10 to the power 9. So 3 3s are 9. Then, okay, so we'll be getting 4 by 3 into 10 to the power minus 19 coulomb. Okay, so we need Q square only because later we need to calculate the force on B, which is exerted by C. So Q square is needed here. Okay, so the first question is, what electric force does C exert on B? So FBC is equal to K into Q square by BC square. Okay, so FBC is equal to K in K, the value of K is 9 into 10 to the power 9. So 9 into 10 to the power 9, and Q square is 4/3 into 10 to the power minus 19, and the value of BC is 0.01 square. So this is 12 into 10 to the power, this is minus 10 divided by 10 to the power minus 4. So this would be 12 into 10 to the power minus 6 Newton. So this is our first answer. So the force C exert force on B, which is equal to 12 into 10 to the power minus 6, and the direction of this force is along BA. That means this is the direction of this force, because this is a repulsion force, so obviously this is the direction of FBC. Okay, and the next question is, what is the net electric force on B? So from the diagram, it's very obvious that both of these forces are opposite to each other. That means the net force would be, so second one, net force at B is equal to FBC minus FBA. So FBC is 12 into 10 to the power minus 6, and BA is 3 into 10 to the power minus 6 Newton. So that is equal to 9 into 10 to the power minus 6 Newton. So this is our second answer. So the net force at B is 9 into 10 to the power minus 6 Newton. Question number 13. Two identical metallic spheres A and B, each carrying a charge Q, repel each other with a force F. A third metallic sphere C of the same size but uncharged is successively made to touch the spheres A and B and then removed away. What is the force of repulsion between A and B? So the charges of A and B are Q and the force is F, and we know when the charges are Q, that time the force would be K Q square by R square, where we can assume that R is the distance between these two charges. From Coulomb's law we can write it, right? Now they have said that a third metallic sphere C of the same size but uncharged is successively made to touch the spheres A and B. So first let us assume that an uncharged C sphere is placed in contact with sphere A. So this is sphere A, this is sphere C. Charge of A is Q and charge of C is basically it's uncharged. And when they are in contact, they will share equal charges, right? So that time the charge of A would be Q by 2 and the charge of C would be Q by 2. And then here we have B sphere, charge of B is Q, and this time the charge of C is Q by 2. And then they made to contact with each other. So this time also they will share equal charges. So that time the charge would be Q plus Q by 2 divided by 2, which is 3Q by 4. So B will get 3Q by 4 charge, and this would also get the same charge, 3Q by 4. So this time A has Q by 2 charge and B has 3Q by 4 charge. So the charge of A is Q by 2 and the charge of B is 3Q by 4. Now we have to calculate the force of repulsion between A and B. And again we are assuming that the charges, the distance between these two charges are R. Okay. Acha. So from F dash, we are assuming the new force of repulsion is F dash, which is K Q by 2, 3Q by 4 divided by R square. So K by R square, 3Q square by 8, which is equal to 3 by 8, and KQ square by R square is basically it's F. So the new force of repulsion is 3 by 8 into F. Question number 14. 2 point charges plus 9E and plus E are kept at a distance A from each other. Where should we place a third charge Q on line joining the two charges so that it may be in equilibrium? So here we have 2 point charges plus 9E and plus E, and the distance between these two charges is A. Now we have to place another charge, a third charge Q, on the line joining of these two charges. So we can assume, so the distance of this Q charge to plus 9E is X. So from E2 plus E2 Q would be A minus X. Okay. Now the force of repulsion at Q charge due to plus 9E is F1, and the force on Q charge due to plus E charge, we are assuming this is F2. Now this F1 and F2 is equal to each other, equal and opposite to each other. So we can write that F1 is equal to F2. So F1 is K plus 9e q divided by x square is equal to F2 as k plus e q by a minus x square. So k will cancel out with each other, q will cancel out with each other, e also will cancel out with each other. We'll be having 9 by x square is equal to 1 upon a minus x square. So a minus x square by x square is equal to 1 upon 9. So a minus x by x is equal to square root of 1 by 9, which is 1 by 3. So from here we can write 3a minus 3x is equal to x. So 3a is equal to 4x, or x is equal to 3 by 4a. So the distance, so we have to place this third charge at 3 by 4a distance from plus 9e charge so that it may be in equilibrium. So this is our answer.